So we ended our last lesson, I believe, with creating equations when we were given the graph. So we looked at the graph and we said, oh, there's the y-intercept, and we found a nice other spot and we calculated the slope and we put it into y equals mx plus b. Y equals mx plus b, yeah. And so we did that, but it was all given a graph. Here, we're not going to be given a graph when we do all of this. We're going to be given some other things. So it is good to remember that our formula for a slope, ya minus yb all over xa minus xb, you could flip that around if you wanted, yb minus ya all over xb minus xa, so keep that in mind. You also, or, could have your slope to be yb minus ya all over xb minus xa. There was a video where I did that and the slope came out to be the same. So it doesn't matter which order. As long as it's BA or AB, keep it the same. Now we do have this as our slope. Just as a reminder, our slope is the letter M here, and that is the number in front, which is 3. Now I like to say 3 over 1 because we have a rise and a run component to this. And then our B, which I think I did in blue before, that is the number with no x. That is our y-intercept, in which this case it is a minus 5. So keep that in mind. We started our drawings at a minus 5, 1, 2, 3, 4, 5, way down here. Then we had a slope of up 3 over 1, up 3 over 1, up 3 over 1, and then we connected the dots. That is what we did in the last couple videos. Now we want to continue. We want to write the equation, and we will, we're going to write the equation of the line. I give it a bunch of points, but I think maybe we're just going to have, determine. So sometimes we just want to know, is a point on the graph? So say there's this graph that I drew, and I said, hey, is the point -2 and 1 on the graph? And so you look, okay, 1, 2, up 1. Is that point on the line? No, it's not. And I say, well, is the point, I don't know, 4, 1 on the graph? And so you get 1, 2, 3, 4, up 1. Hey, yes, it is on the graph. So we're going to be looking at that, but we're going to be doing that without actually doing any drawings. And so that is what example 1 is here. Determine which of the following points are on this line. And it's actually really easy. Y equals 2x minus 5. I'll start by writing that down because I don't want to keep looking over there. So y equals 2x minus 5. And the way to tell is to put these numbers, x and y, into this equation and see if you get a true statement. So y is -1, so I'll make it -1. That is our y. I'm trying to highlight. Clearly all I did was scribble. So here's -1, that's our y, so we'll put it in for our y. And then we've got a 2. And we've got a 2x minus 5. So the x in this case will be, and make this a little smaller, that's a little aggressive here. Yeah, so our 2 is right there. And that is our x. So we have to put here in our x, we're going to have to put a 2. So this is 2 times x, so I have to put a bracket, 2 times 2 minus 5. So all I did was just take whatever our x value was and plugged it into the equation, which you should know how to do before. Now that's a -1 on the right side. 2 minus 2 is 4, minus 5. Now what is 4 minus 5? Well, 4 minus 5 is -1. And the left side is just -1. So did we get a true statement? Does -1 equal -1? Yes. So yes, it is on the line. If you get a true statement, then you get, yes, this point is on the line. Again, all I did was put the x into here and the y into here, and they did some really simple math, and I got a true statement. So let's keep going here. Was it 2x minus 5? So I'll start by writing it down because I keep forgetting. Y is equal to 2x minus 5. So in this case, our x is there and our y is there. X is always first. So instead of y is -6, and 2 times x. X here is -1 minus 5. So there's nothing to do on the left. That just stays negative 6. 2 times negative 1 is going to be negative 2. I have to do that first before the minus 5 just because it's bad math. So 2 times negative 1 is negative 2 with that minus 5 there. And then, of course, there's nothing to do on the left. But on the right, negative 2 and negative 5 get me a negative 7. So is that a true statement? No, it is not. So no, this point is not on the line. So not on the line. And let's try the last one here. So again, this is our x and this is our y. So we've got y equals 2x minus 5. Now y is going to be 1. So I'll make this a 1. And this is 2 times x. X is 3. So I'll make that a 3. 2 times 3. Minus 5. Again, there's nothing on the left to do, so that's just a 1. Bed mass is 2 times 3 first, which is 6. And there's a minus 5. Nothing to do on the left. And then 6 minus 5 is 1. Does 1 equal 1? Yes, it does. So yes, this point is on the line. So not on the line? Nope, this is on the line. So you can write on the line. So that's just checking to see if points are on the line. It's just a good thing to know. But it's not what we're going to be working on moving forward here. So determine which of, I spoke too soon. Determine which of the following points are on the line. We're going to do this again. But like I said, these are not what is going to be used to determine equations. But it is really good to know how to do this stuff. And I like this one particularly because it's got some fractions. So y equals negative a third x plus 6. So maybe I'll write it over here. Y equals a negative a third times x plus 6. So x is there, negative 3, and y is 5. So I'm going to put 5, and then negative a third times x. X is 3. Nope, negative 3 plus 6. Now left is only a 5. Now negative a third times 3. Well, this just becomes 1. If you have 3 times a third, those end up canceling out. If you wanted to do it as a fraction, you could just make a little note to yourself. This is technically over 1. And so then you would have negative 3 times negative 1 times negative 3. Just multiply the tops together, which is 3. 3 times 1, which is also 3. And then you have a plus 6. And I'm just going to double check here. Yeah, I have done that right. And then 3 over 3 is just going to be 1. So I'm just going to erase that and make this a 1. And then 1 plus 6 is 7. Is that a true statement? No, it is not. So no, it is not on the line. Let's try the next one here. This is our x, and this is our y. And our equation was y equals a negative a third x plus 6. So our y is 6. And we have a negative a third times x. X in this case is 0 plus 6. Now 0 times anything is 0. So 0 plus 6. And 0 plus 6 is 6. So is this a true statement? Yes, it is. So yes, this is on the line. Whereas the other one was a definite no. And let's try the last one here. This is our x and this is our y. So we have y equals negative a third x plus 6. And we can put this point in. So y is 2. And this is negative a third times x. X is 12 plus 6. Now again, keep this in mind. This is over 1, so you can multiply the tops together. So this is just a 2. But multiply the tops. Negative 1 times 12 is going to be a negative 12. 3 times 1 is going to be a 3 plus 6. Now negative 12 over 3 is going to be a negative 4. 12 divided into 3 groups. Each group has 4. And then negative 4 plus 6 is 2. So 2 equals 2. So yes, this point is on the line. I like that question because you have this 12 over 3 thing that you need to figure out. So I'll end the video here, and this was just determining if points were on a line. The next one will actually go to create equations, which is what this section is about.